basically, new technologies don't typically transform economic institutions. They improve productivity. They may drastically affect certain industries. Occasionally, we see bigger changes. The second industrial revolution was one of them, where we saw a host of companies that all benefited from economies of scale in steel production, oil, sugar, many other industries. And this introduced new types of firm organization. The second industrial revolution introduced managerial hierarchies. It changed labor markets. We saw industrial unions. It changed the nature of innovation from individual inventors to R&D labs. It changed the nature of competition, the rise of monopolies, or what were called trusts in the US. And it also changed regulation. So as these companies became more powerful, some of them abused their power, sparking a reaction movement, a progressive movement that introduced regulation of all sorts of things, from child labor standards to anti-monopoly. So I'm arguing that today we're seeing a similar vast change taking place, that we're seeing new forms of organization, companies built on platforms, and I'll talk about what platforms are a little later, both internal and external. We're seeing a change in the nature of competition. We're seeing a decline in the rate of creative disruption. We're seeing growing industry concentration as the top firms get larger and more persistent. We're seeing changes in the innovation pattern, slowing of the diffusion of new technologies, a gap between the best and the rest, slower productivity growth. We're seeing changes in labor market, a skills gap where our method of giving workers the skills they need to work with the latest technologies are not working as well. And we're seeing greater wage inequality, in part because of that. And we're seeing government regulation become less effective, that the balance between major corporations and government is changing. And the basic idea here is that information technology changes how firms use information, and that changes the economy. Joanna talked about automation, and there's a lot today to talk about automation. I'm not going to really be talking about that in this talk. Automation creates jobs as well as replaces workers, but it's not transforming the economy as some of these other changes are. Automation does impose transitions on workers. They need new skills, new jobs, new occupations. There are social costs to that, so it's an important issue, but it's not what I'm going to be focusing on today. So first, organization. Let me talk about one technology, the barcode scanner. These were introduced in the US in the 1970s. It allowed smaller chains of retailers in grocery or merchandise markets to adopt this technology and do some things that the bigger chains previously could do. It provided them an advantage. They got greater revenue per worker. Their costs went down. One company, though, at that time was a small chain in the southeast of the US called Walmart. They not only took that technology, but they built it into an integrated system. That they had a satellite system that connected all of their stores and distribution centers and headquarters, and also some suppliers. And what it meant was what it meant was they could communicate and distribute data differently. So the second industrial revolution was based on economies of scale. There were these large centralized enterprises. Part of that occurred in retail. The notion of chain stores grew up and occupied dominant roles in many retail sectors. But the chain store was built on the idea of standardized store selection, centralized buying, centralized warehouses. Standardization was the key. They could sell the same groceries in 3,000 stores across the country, and they could do it efficiently because they were selling the same goods coming from the same warehouses and being bought by the same buyers. So they had all sorts of middleman efficiencies to gain. But in this model, the headquarters was central. They achieved that efficiency through standardization, but it was the buyers in the central headquarters that coordinated everything. The Walmart model opens up communications and control decision-making to everybody, not only headquarters, but individual store managers or even suppliers. They can all check what's selling at each store, each cash register if they want. They can notice when stocks are getting low. They can quickly determine what's hot in what area and what's not selling well in other areas and change the mix and respond to changes in demand. So they're able to stock many more items per store. So there's much greater selection, which is attractive to consumers. They can respond quickly to changes in demand, and they can also tailor demand to different regions effectively. In this process, they can reduce their warehousing and distribution costs.
Let me get this on my head for a second.
Hello? They cut their costs, which allows them to pass that on to their consumers in the form of lower prices. And so they're able to gain not only the efficiency, but also the heterogeneity that didn't come with the earlier model. And as a result, Walmart was very successful. It became the largest retailer in the world. Its share of the general merchandise market in the US grew from 3% to 52% by 2012. So, a dramatic change. So what is it that information technology does here? We typically talk about the advantage of information technology being that it allows low costs. Low-cost computers, software is a fixed upfront cost. It's cheap to reproduce. The feature I'm going to highlight here, and those are true, but they're not really related to what's going on now. The change now is that software is very good at modularity. Software enables a new feature, a new product to be added to store variety very easily. It allows new product features to be tailored very quickly and easily. It allows greater targeting and customization, things that would, a typical automobile manufacturer takes a much longer period of time to develop a new hardware-based feature than it takes to change the software that's already there in the cars. So this modularity reduces the cost of managing complexity, and managing complexity is something that many sectors of the economy do. So in retail, it improves logistics and inventory management, allows better selection, faster response. We see this with Walmart, we see this with Amazon. In manufacturing, we're seeing many more features being introduced cheaply. It still makes the design more expensive, but we're seeing aircraft, for instance, a whole new a major jet requires 25 or 30 billion to design these days. A new automobile starting from scratch requires 5 to 6 billion, and these are huge software investments, 100 million lines of code. We're seeing targeted advertising, as we're all very familiar with Google and Facebook and whatever, targeting things. We're seeing finance offering targeted credit offers so that the banks can tailor credit card offerings or home equity line, and they not only know which packages are going to be most appealing and most profitable for different consumers, they can target the marketing to those consumers. So we see in the US, the top 4 banks are responsible for 57% of the credit cards issued. So this competing on complexity, it's not just about big tech, it's about many sectors of the economy, banks, insurance companies, pharmacy benefit managers, waste management companies even. I estimate that about 45% of industries that account for 71% of revenue are making these large investments in software systems. We're seeing a huge amount in the US. It's 250 billion is being invested annually in firms' own software development, and almost all of this is large firms, and that doesn't account software they buy from somebody else. This doesn't account for all the hardware that goes with it or the organizational changes that go with it, but these are large investments. They're dominated by the big firms. So if we look at the share of software workers, it's the big firms that are responsible for them, excluding the tech firms from this. And what they're building are platforms. So it's not just the software, it's also the hardware. It's also organizational changes. For instance, Walmart introduced a new type of retail organization, and it's data. So when we think about platforms, when the term gets used, I think most people, the public discussion focuses on what I would call multi-sided open platforms, but that's only one flavor of platform. So Walmart itself is a platform. It is a multi-sided platform. In other words, you've got different players. You've got the store managers, headquarters, suppliers, but it's an internal one. It's closed. Only Walmart employees or their suppliers get to see it and use it. In contrast, an open multi-sided platform is something like Amazon Marketplace, where you've got sellers, you've got Amazon providing the platform, you've got direct consumers who purchase things online. You've also got one-sided platforms, the Amazon Cloud Service, for instance, at least initially, just had the platform providing the service to its users. Now they have third parties introducing products, and it's become multi-sided. But initially that was closed. Initially that was a proprietary internal platform that Amazon used to manage its websites. In 2006, they opened it up so that other people could use the services for a fee, of course. And that spawned the cloud computing industry. But all of these, we think, are platforms, and they're the essential building block of this new economy. All right, so what else does it change? I mean, that is a change in organization. It changes, we're seeing changes in competition. So there's rising evidence that the share of the market controlled by large firms is growing, has been growing for 20 years. So this shows manufacturing in the US, the share of the top 4 firms has gone up 4 or 5%. Here shows data on the top 10% of firms in Europe in manufacturing and in services. These are broad. The majority of industries are seeing growing concentration or growing dominance of large firms. And we're able to relate that to software use in the industry. So this shows the market share of the top 4 firms across US industries or by the software share of the workforce. In other words, how many software developers are employed as a share of the total workforce in these industries. And what you see is, and again, we're excluding the tech sector itself, but where software becomes a major part of the workforce, software developers are a major part of the workforce, we're seeing higher levels of concentration and also greater increases over time. We've got some research which shows that this is plausibly a causal effect that flows from the share of developers to industry, the rise in industry concentration, and the increase in the role of proprietary information technology, that is the stuff that the big companies invest in their own technology, is in fact accounts for much of the rise in concentration. So this sort of rubs against the myth that new technology disrupts everything. It's not so much true anymore. For one, these are proprietary systems. They're for the firm's own use. These are not general purpose technologies. Walmart does not license its software or systems to other companies. It doesn't sell them as, a packaged software product. These are internal platforms, and they're slow to diffuse, to spread. They're not licensed. they're hard to imitate. So here, it has a different effect on this disruption. This is the disruption rate measured as, this is essentially the probability that a firm that is in the top 4 of its narrow industry is no longer in the top 4 years later. So during the late 90s and 2000, around 2000, disruption rate peaked. It was very high, but it's come down sharply since then, about half the level. So the probability that a firm stays in the top 4 is much greater today. These firms are much more persistent. These are select platform firms. They have a competitive advantage because of their technology. They're able to grow their market share. As a result, rivals grow more slowly, and so we have rising concentration. And they're more persistent. They're less likely to get disrupted, less likely to be leapfrogged. It's harder for a second-tier firm to leapfrog into the top 4. All right, the third change is in innovation. So the innovation process, people tend to focus very much on creating new ideas, but it's not just creating them, it's also spreading them or diffusing them, as economists like to say. The new technology to affect society to the greatest degree has to be used broadly. That happens a number of different ways. One is by licensing. So when General Motors developed the automatic transmission, it licensed it to many of its competitors. Diffusion also happens as the more productive firms grow. This is sort of the Schumpeter story where an innovator comes along and grows bigger and bigger until it displaces or disrupts the incumbent using older technology. Diffusion also happens by spin-outs and spin-offs and that sort of thing. Well, it's happening less rapidly today. We're seeing a growing gap between the leaders and the rest, between the biggest firms and the rest. This is data from the OECD showing a gap between the frontier firms and the laggards. Here is showing U.S. public listed firms, the revenue per employee between the top 4 firms in their industry and the rest. Before 2000, they were roughly, the top 4 firms had roughly the same productivity as everybody else, maybe even a little bit less. Since 2000, there's this growing gap where the revenue per employee or the labor productivity is much greater for the dominant firms, for the leading firms. That is evidence of slower diffusion, that the technology that the leaders have just isn't getting around as much. That automatic transmission technology, it's spread to basically the entire auto industry within 10 years of its introduction. So we're seeing something that's much slower today. And what this means is that there's much less access to the technology for smaller firms and for workers who want to gain skills using the new technology. And these have important secondary effects. So why is it that it's diffusing more slowly? I think there are a number of reasons. One is that a lot of this technology is being used to differentiate firms rather than to simply make them more efficient. When that happens, a firm may not want to license to its rivals. So Walmart doesn't want to license its technology because, if its competitors can stock their warehouses as efficiently and increase the number of items in their stores, Walmart loses its advantage. But also, I think it's because these platforms are very complex. They involve a mix of software, data, hardware, personnel, and it's difficult for anybody else to imitate that. Firms can choose to unbundle their software, and I'll talk about this later, as Amazon did with AWS, with its IT infrastructure. It's a different story. It's also true, the diffusion is also slow because productive firms are growing at a slower rate. And we're also seeing declining employee mobility in the US. So it's not that there's a shortage of new ideas. This shows the new entrants and new tech entrants. You can see that the number of new tech firms being created is a bit lower than it was at the peak of the dot-com boom, but it certainly hasn't slowed down, and it's higher than it was in the 1980s and 1990s. There's no shortage of venture capital either. We're seeing peak levels of venture capital funding, or at least we were before the pandemic. But we are seeing more productive firms grow more slowly. So this is the relationship that's sort of key to moving the aggregate economy forward, that the growth rate of firms is greater if the firm is more productive. This is what we like to see in the Schumpeterian story. The firm with the most productive technology should grow faster and overtake the less productive incumbents. What's happened, though, is that the growth rate of productive firms has slowed down after 2000. We're seeing a shift in this curve where the most productive firms are going to grow maybe at half the rate that they grew 20 years ago. That's very troubling, and in fact, researchers at the census have attributed much of the productivity slowdown to that trend. So how does this happen? Why is it that firms are growing more slowly? You can see some examples. Fintech firms in the US have difficulty accessing consumers' data because the big banks are blocking them. Now, that's different in the EU now and in some East Asian countries because they've passed laws requiring banks to open access, but that means fintech, these firms can be very innovative, very productive, but they grow more slowly. Innovative retailers can't handle a large selection. So even though they may have, new ideas about retailing, innovative concepts, more efficient ways of doing things, they have a hard time competing against Walmart with its huge product selection. Even big companies such as Google has difficulty competing against Microsoft Excel, for instance. Google Sheets has had limited success despite having some better features for working together. But when you look at feature counts, the problem is Google just hasn't created the huge number of features that are in Excel. 3,000 features. Microsoft Office has 12,000 features. It's a huge thing. Most of us don't use most of those features most of the time. But for people who want to do that particular thing with equations, for instance, the Google Sheets product has some significant limitations, and it has a hard time growing, even though it's often offered for free. So we're seeing this slowdown. As I mentioned, it's been attributed as a major source of the slowdown in aggregate productivity, and that's a change in innovation. Okay, labor. I'm running a little behind here, so I'm going to speed up a bit. So the idea is only limited.
Yeah, sorry, it's too interesting. I haven't been stopping you, but you're right. You're 5 minutes over, but let's go another 5 minutes.
Yeah, I started a little late too. Anyway, when only select firms have access to the technology, it means they're willing to pay more for workers who have the skills, and we see big gaps in pay for essentially identical jobs across firms, and much of this is driven by the extent to which they are investing in software developers and software development. So the same thing is driving about a 20% difference in pay premiums between firms. It turns out that most of the rise in inequality since 1980 has occurred between firms rather than within firms. In other words, it matters now not so much what education you have and what skills you've got, but it also matters, your pay matters, who you work for. It becomes harder to gain experience when only select firms have the technology. So we see a skills gap where there are, the demand for people who know data science in a variety of occupations from marketing on, it's difficult to find people. And there are talent wars where startups now have to pay premiums to compete with the superstar firms that are paying these high wage premiums. So the entire method by which we produce a trained workforce has slowed down and has some significant problems. Last point, regulation. Now that things are driven by software so much, there's a new set of challenges. So Dieselgate is an example. The automobile I mentioned has 100 million lines of code. It became very easy for Volkswagen engineers to tweak that code so that they could fake out the emissions tests. This turned out to be not only Volkswagen, but I think 11 different companies. It was hugely costly for Volkswagen, but it shows a major difficulty with regulation. Regulators are ever more dependent on information for a variety of reasons, and software makes it more difficult for them to get that information. So we see problems with software evading regulation in Volkswagen, the Boeing 737 MAX, the subprime mortgage collapse in the US. All of these were all cases where complex software systems were hard to manage. They were also hard to manage in some cases where the companies themselves, corporate managers, didn't necessarily know what was going on. But there's certainly make a government regulation more difficult. All right, so I'm arguing that we're seeing these changes in organization, in competition, innovation, labor, and regulation. Where do we go from here? There are real benefits to this new technology. It's meeting consumer needs better than before, but it's creating these other problems that are troubling at the very least. So one positive development is unbundling, something like I talked about with Amazon. Amazon had this superior infrastructure. They opened it up for a fee and made it available to small firms as well as larger firms, including Amazon competitors. It's been established that this has been a boon to productivity for smaller firms. It allows these firms to access the most advanced capabilities, and it's increased competition. It also provides opportunities for abuse, but overall, it's the kind of thing that would solve many of the problems caused by this new generation of technology. What about government? I mean, it's clear that government needs to have more access to code and data to enable regulation, to prevent some of to just simply perform the role that it's been assigned to perform. But I think more generally, government can encourage unbundling, can encourage firms to open up aspects of their code or data. One is to encourage employee mobility. There have been a number of things in the US at least which have discouraged mobility, but also antitrust regulators have opportunities and industry regulators have opportunities to encourage data sharing or open access to platforms. For instance, the example of the fintech companies gaining access to bank customer data. Also, government has a role to play in education. The way we are acquiring skills today has to change. That's a whole other discussion, but obviously talking about lifelong learning, ways of getting experience with new technology are important. The kinds of focuses that government has been applying to digital technology may be positive, but they're not addressing the full problem I'm outlining here. So in the EU, for instance, we have a database right, the GDPR on privacy, the Digital Services Act, Digital Market Act. These are focused on on social media and the largest open platforms. The AI Act is coming along. In the US, we're seeing some similar but lesser movements. But to some extent, the focus of these is not really addressing the larger problem that I'm raising here. First off, big tech isn't the problem. Big tech is only 3 to 4% of US gross output. The software intensive industries are 71% of gross output. It's a much broader swath of the economy I'm talking about. Nor is it only U.S. firms. Some of the EU regulation seems to be targeted at U.S. firms, and it would be perhaps more beneficial if it looked inward a little bit. And open platforms are part of the solution. So this is, I think, a tricky area. Open platforms have been demonized to some extent in the recent antitrust discussions, and it's quite clear that open platforms open opportunities or create new opportunities for abuse. So they do require greater antitrust oversight. On the other hand, open platforms can encourage massively greater competition. And so we want to encourage them. They're part of the solution. So I think there's sort of a difficult or sensitive line that the regulation needs to pay attention to. So in conclusion, and I hope I'm not too over late here, software is changing the nature of competition in many industries, in many ways, and we're really looking at a new technological economic paradigm, and it requires a new approach to thinking about regulation. Thank you.
Okay, well, that's absolutely spectacular. Thank you so much.